The board in front of me was pulled from a fence that went into the ground in 1887. I know that because the deed says so. No rot, no gray. The grain is tight and dark, and when I press my thumbnail into the wood, it does not give, not even slightly. I am in Lancaster County, Pennsylvania. It is 94 degrees, and this post has been standing through every summer since Grover Cleveland was president. 6 months ago, I would have called someone a liar for telling me that was possible. I spent 30 years replacing fence posts every decade, watching decks go gray by year 3, spending money I did not need to spend on treatments that never lasted. I thought that was just how wood worked. It is not how wood works. There is a formula, 3 ingredients, less than $2 per application that the wood treatment industry buried starting in the 1940s. I found the proof in Mennonite agricultural records from Lancaster County. Real entries, real dates, a specific technique written in the margins of farm maintenance logs that nobody in any YouTube channel or home improvement magazine has ever discussed. And what I am about to show you works on wood that is already graying, already cracking, already installed in your yard right now, not just on new construction. What I found next stopped me cold. The oldest known pine tar production facility on Earth was discovered in Sweden. Radiocarbon dated to somewhere between 540 and 380 BCE. That is not a typo. 2,500 years ago, Scandinavian craftsmen were already processing pine resin into a wood preservative so effective that Vikings used it centuries later to seal their longships for crossings in the North Sea. Those vessels sailed through some of the harshest conditions on Earth: salt spray, freezing temperatures, constant moisture loading, and the wood held together for journeys that took months. Pliny the Elder documented the same chemistry in 23 AD. Roman builders mixed pitch and linseed oil on structural timber because they understood something modern contractors have been paid to forget. This was not folk medicine or old wives' knowledge. This was the engineering standard of every civilization that needed wood to last generations. By the late 1600s, pine tar had become Sweden's 3rd largest export commodity. They called it Stockholm tar. The British Royal Navy depended on it completely. Colonial shipyards running up and down the eastern seaboard ran on it. That is where the nickname Tar Heels comes from. Not a football mascot first, a real industrial legacy. The pine tar production in North Carolina was so massive, it supplied the naval infrastructure of an empire. And the formula those builders used was simple. Boiled linseed oil, pressed from flax seeds and treated with metallic drying agents to accelerate curing. Real turpentine, distilled directly from pine resin. Pine tar, specific ratios, mixed in a jar, applied with a rag. That combination does something no synthetic product has ever fully replicated. It does not coat the surface of the wood, it enters the wood. Linseed oil is a triglyceride with an extremely high concentration of alpha-linolenic acid, a polyunsaturated fatty acid that reacts with oxygen inside the wood fibers through a process called autoxidation. Those fatty acid chains cross-link with each other and form a flexible polymer network that fills every microscopic pore from the inside. Penn State Extension researchers confirmed that boiled linseed oil penetrates up to 4 times deeper into wood fiber than polyurethane. 4 times deeper. And unlike polyurethane, the protection forms inside the grain, not on top of it. But there is a second ingredient in this formula that changes the entire picture. And the history of why it disappeared from hardware store shelves is one of the most deliberately ignored stories in American building history. I had always assumed that what you buy at a hardware store is what has always existed. That turpentine was turpentine. That if they sold it, it worked the same way it always did. That assumption cost me decades of unnecessary maintenance. Real turpentine is distilled directly from the living resin of pine trees. When a pine tree is wounded by a branch breaking, by an insect boring into the bark, it immediately floods that wound with resin. That resin is chemically engineered by millions of years of biological pressure to accomplish 3 things simultaneously: repel insects, stop fungal growth, and permanently seal the damaged wood against moisture. That is pine resin. When you distill it, you get real turpentine. It smells like Christmas trees. That is what the formula requires. What the big box stores sell today labeled as turpentine is not that. It is a petroleum derivative, a synthetic industrial solvent that shares a name with the original product and almost nothing else chemically. It has a sharp, unpleasant chemical odor. It carries none of the biological compounds that made the real product effective on wood over the long term. The substitution happened quietly during the post-World War II petrochemical boom, when synthetic solvents became dramatically cheaper to produce than harvesting pine resin at scale. The longleaf pine forest that supplied real turpentine production across the American South had been heavily deforested. The industry saw a clear opening replace a natural product with a synthetic one, call it by the same name, and move on. The price margins were better, the supply was more predictable, and nobody organized a campaign to inform homeowners that what they were buying bore the same label as something entirely different from what their grandparents used. Real turpentine from pine resin is still available today, but you will not find it at any major home improvement chain. It comes from specialty suppliers, sometimes imported from Portugal or France, where longleaf pine forests are still managed for resin harvesting. It costs more per quart than the synthetic version, but it is the ingredient that makes the formula behave the way it is supposed to behave. Pine tar, the third component, amplifies everything. Pine tar comes from heating the resine-saturated heartwood of old-growth pine until it breaks down into a thick, dark, aromatic liquid. It carries every compound the tree accumulated over decades of self-defense, antifungal acids, insect-repelling terpenes, resin compounds that bond permanently to wood fiber. When you work it into a fence post or a deck board, you are putting the tree's own immune system back inside the wood it came from. The formula, boiled linseed oil, real turpentine, pine tar, costs approximately $2 per application per board at current material prices. The protection is internal. A scratch on the surface does not compromise it because there is no film to crack. There is no surface coating at all. Therefore, when synthetic products flooded the market in the 1940s and 1950s, traditional builders who knew this formula did not abandon it because something better had arrived. They were simply never told they had a choice. And within one generation, the knowledge stopped being passed down. When I understood all of this, the first thing I thought about was my own house, built in 1974. Nothing special, cedar siding on the back, a fence around the property I had repainted twice in 15 years, and a set of wooden porch posts that were starting to check and gray along the grain. I was not building from scratch. I was not starting a new project with fresh lumber. I was looking at 50 years of installed, weathered, existing wood, and I want to tell you exactly what I did because it is something you can do this weekend. I went to a hardware store and bought a quart of boiled linseed oil, $8. I ordered a pint of real turpentine from a specialty supplier online, $14 for more than I needed for this project. Total materials, $22. Cost per application, less than $2. I started on the fence. I took a stiff, natural bristle brush and swept loose dirt and cobwebs off the boards. No power washing, no sanding, no chemical stripping. I mixed equal parts boiled linseed oil and real turpentine in a wide-mouth glass jar, sealed the lid, and shook it for 30 seconds until it clouded into a golden emulsion. Then I applied it with a clean cotton rag using firm strokes along the grain, working in 2-foot sections so the liquid had time to absorb before I moved on. What happened on the first board stopped me. The gray oxidized layer on that cedar visibly dissolved within 30 seconds of contact. The golden oil flooded into the exposed grain so fast I could watch it disappear into the wood. The board changed color in real time from washed out silver to a warm, tight, dark grain the way it looked when it was first installed. I let the first coat absorb for 15 minutes, wiped any excess with a dry cloth, and moved to the next section. Within 2 hours, I had covered the entire fence. Within 48 hours, the wood had settled into a color and texture that I had not seen on that fence since I moved in. I did the porch posts the following morning. Same method, same result. Then the cedar siding on the back of the house, which had been silvering and beginning to lift at the edges. One application, 40 minutes of work. The siding looked 10 years younger. Not painted, the grain was still fully visible, changed from the inside out. For a 200 linear foot fence, the total material cost at this formula's dilution runs between $15 and $20. The contractor estimate I had received for the same job was $1,100. I did it on a Saturday afternoon, and the result was better than any refinishing job I had seen attempted with commercial products on my street. For dense hardwoods, oak posts, hickory tool handles, structural beams, there is a heat application method that takes this further. You warm the boiled linseed oil to about 140 degrees using a double boiler, never over an open flame. Then you apply it to wood. You have also warmed slightly with a heat gun. Hot oil penetrates 3 to 4 times deeper than cold application on dense grain. One treatment done this way can last 10 to 15 years on a structural beam. One safety note I will not skip over because it is not optional. Rags soaked with linseed oil can spontaneously combust if left bunched in a pile. The curing process releases heat, and a crumpled rag holds that heat and can reach ignition temperature on its own. A fire started by linseed oil-soaked rags in Philadelphia in 1991 killed 3 firefighters. Always spread your application rags flat outdoors to dry completely, or submerge them in water in a sealed metal container before disposal. Every can of boiled linseed oil says this on the label. Read it and follow it. The formula is safe when handled correctly and dangerous when it is not. Now let me tell you why this knowledge costs $2 to implement and $15 billion per year to suppress. The wood treatment and deck product market in the United States generates over $15 billion annually in revenue. That number is sustained by one operational assumption that you will go back to the hardware store every 2 to 3 years because whatever you bought last time wore out. Thompson's, Water Seal, Cabot Australian Timber Oil, Ready Seal, Olympic. These are not fraudulent products. The chemistry functions. But the active ingredient in the majority of oil-based wood restoration products is the same drying oil mechanism that has existed since before the Roman Empire. They are selling you linseed oil chemistry with synthetic additives and a recognizable logo at a markup between 10 and 50 times the raw material cost. In 2003, the EPA forced the residential lumber treatment industry to stop using CCA chromated copper arsenate on lumber sold for home use. Arsenic. The industry had been treating the wood in children's playground equipment and backyard decks with a substance containing arsenic, and it required regulatory pressure to end it. The builders who used the linseed oil and pine tar system never needed the EPA to intervene. Their formula was already safe, already effective, already proven by 2,000 years of continuous use across multiple continents. The formula cannot be patented. You cannot patent linseed oil. It is a natural product that predates the patent system by centuries. You cannot patent vinegar or turpentine or pine tar. There is no proprietary molecule, no trade secret, no intellectual property to protect. And what cannot be patented cannot generate licensing revenue. What cannot generate licensing revenue cannot be advertised. And what is not advertised disappears from public knowledge one generation at a time, until a homeowner staring at a gray deck types into a search engine and the first page of results is dominated by sponsored products selling him the chemistry of linseed oil in a branded bottle at 40 times the raw material cost. That is not a conspiracy. That is just a market that rewards complexity and punishes simplicity. The $2 solution does not get promoted. It has no marketing budget. It has no television commercial. So it vanishes, and the cycle continues. But there is a final step that I have not mentioned yet. The reason some wooden structures survive 150 to 200 years is not the oil treatment alone. I found it in a source I almost did not think to check: a digitized archive of Mennonite agricultural records from Lancaster County, Pennsylvania, farm management logs from the 1800s, building maintenance notes written in pencil in the margins. I was searching for application quantities and ratios. What I found instead was a phrase repeated across multiple entries in multiple years: after oil cure, wax coat. After oil cure, wax coat. Beeswax. After the boiled linseed oil treatment has cured for 48 hours, traditional builders applied a final coat of beeswax melted with a small amount of warm linseed oil. The wax was worked into the surface while still liquid using a soft cloth and wiped smooth. It set within hours to a low, warm sheen. Here is why that step changes everything. Linseed oil is extraordinarily effective at protecting wood internally against moisture and fungi. But it has one specific vulnerability that the modern woodworking world does not discuss: ultraviolet light. Prolonged UV exposure over many years will gradually break down the oil's polymer chains at the outermost surface layer, leading to slow surface graying even in treated wood. This is manageable with annual maintenance coats, but beeswax addresses it entirely differently. Beeswax contains naturally occurring UV-absorbing compounds. The same reason honeybees build their combs from it, it resists degradation from sunlight. When applied over fully cured linseed oil, the wax creates an external barrier against ultraviolet radiation that the oil alone cannot provide. The oil protects the interior of the wood against moisture and biological decay. The wax protects the oil itself against solar degradation at the surface, one working from the inside out, the other working from the outside in. Applied together in sequence, they address every mechanism through which wood fails. A 1-pound block of beeswax costs $8 and treats an entire fence. Applied once every 5 to 7 years over an existing linseed oil treated surface, it extends the protection almost indefinitely. Total materials to treat a fence that will last a century, approximately $25 once. The Mennonite records note this step so routinely that the writers clearly assumed any reader would already know the oil application came first. By the time those records were written, the combined system was so standard it barely warranted explanation. Nobody buried it intentionally. The synthetic product revolution simply made it irrelevant to manufacturers, and the irrelevance became invisibility, and the invisibility lasted long enough that an entire generation of American homeowners never heard it. Now you have... I spent 30 years replacing wood that never needed to be replaced. Paying for refinishing jobs and contractor visits and branded products for surfaces that could have lasted a lifetime on $25 of materials and one afternoon of work. That is not a home improvement story. That is 30 years of a system operating exactly the way it was designed to operate. You and I now share something that $15 billion a year depends on us not knowing. 3 ingredients: equal parts oil and turpentine with pine tar for exterior posts, 1 final wax coat after the cure, a glass jar, and a cotton rag. The formula is not complicated enough to forget. I want to ask you one specific thing before you go. Find the oldest piece of wood on your property right now, the fence post, the porch beam, the window frame, the barn siding, and leave me a comment with the year it was installed. Just the year. Nothing else. I want to know how much time the industry has been telling you that wood is supposed to fail. Write it right there below this video. I will read every single one. The wood treatment is just one of 5 systems in the Amish Home System guide, the complete step-by-step for cutting every household bill to zero using methods that were standard before the industry decided you should keep paying energy, water, fuel, heat, wood, all covered, all for any home you already own. Link in description. If you know someone looking at a contractor quote for a fence or a deck right now, share this with them today, not tomorrow. The quote expires, the formula does not. I keep finding things like this. The next one is about wood shingles treated with a technique that costs almost nothing per square foot and that the insurance industry has quietly worked very hard to make sure never appears in any guide that homeowners actually read. That story is coming. Stay close.